To begin with, let's look at a really simple question. What's the matter with you? Everything around us is made from matter, from this sandwich to this car. We ourselves are made exclusively from matter. So really, the answer to the question, what's the matter with you, should be as follows. But what actually is matter? Einstein would have said that it is a condensed manifestation of energy, as according to his famous equation, E=mc². If we're to humour Einstein for a moment, and after all, he is a pretty smart guy, we're presented with a rather troublesome possibility. Let's take a moment to look where E=mc² comes from. The following equation gives the energy of any particle. However, when the particle is at rest, the term containing momentum can be ignored as it has none. This equation is normally square-rooted to give the simplified form E=mc². However, since squared always has two possible solutions, the actual equation should be E =± mc². This implies that there are two matter solutions to the equation E=mc², and also predicts that for every fundamental particle there is a second antiparticle. For the electron, this particle is the positron. For the proton, the antiproton, and for the neutron, the antineutron. It is even possible for these antiparticles to form their own antiatoms, such as the antihydrogen shown. Matter and antimatter have opposite charges, and when they come together they annihilate, as shown by the following. This idea of annihilation, while currently in its infancy, has the potential to be very useful to humankind. The graph shows the relative efficiencies of nuclear fission and antimatter as power sources. As you can see, antimatter is roughly 33 times more efficient than nuclear fission. It would also require 8 million kilograms of TNT to produce the same energy as the annihilation of 1 kilogram of antimatter. However, we still have a long way to go. Antimatter requires vast energy to create and has an estimated current cost of £31,250,000,000 per milligram. One scientist from Livermore Labs, in a lifetime creating antimatter, claimed to have made just enough to boil his kettle. Because antimatter would annihilate with any container made of matter, it is rather difficult to store. To contain antimatter, we have to use vacuum chambers and electromagnets, and now it's time to change things up a bit. Antimatter could well be the solution to many problems, so let's take a look at one specific example. An antimatter spacecraft works under the principle of a ship suspended underneath a uranium sail. Antimatter particles are fired at this sail, which induce antimatter-matter collisions as well as nuclear explosions. Rather like creating its own wind, these explosions generate enough thrust to propel the spacecraft roughly 20 times faster than current propulsion methods. Now we've saved the world, it's almost time to leave. But please bear in mind that this technique will only work in space where the antimatter has no chance of interacting with any other matter. Thanks very much for listening, and we hope we've inspired you to delve even deeper into the world of antimatter.